Hello, I welcome you all. The problem reads, the hook supports the 4 kilonewton load. Determine the internal normal force, shear force and moment at point A. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a hook supporting a 4 kilonewton, and we've been asked to find the internal forces, normal shear and moment force at A. So we're going to section this part here. When we section, we have the lower section and the upper section. Okay, I'm going to use the upper section. So let's draw the free body diagram for the upper section. It doesn't matter which section you use. You can use the lower or the upper. I'm using the lower section. So we have this circular hook like so. Okay, like so up to somewhere there. So let's say this point is A, and then let me say I have my normal force like so here. I mean my shear force, sorry. I have my shear force. This is my shear force, VA. And then I have my normal force. My normal force looking like that. This is NA. And then I have my moment, which is MA. Okay. And then I have my center of this circular hook. The center is going to be somewhere here. And the radius for this is the radius for this hook is 75 millimeters, right? And then from this point to A, and this angle here, we've been given this angle is 45 degrees. Okay. Let me just redraw this. So let it be something like this. Okay, great stuff. Okay, all right, so something like that. So that's my VA. So this is what we have at the moment. So I'll need to find, I'll start with first finding the moment, and later on I'll need to divide the shear and the normal force into X and Y component, since this is our coordinate system. Okay. But we need this for us to take moments about A. We need this distance here, you know. Look at this distance from A. So there is this distance here, okay. Okay, when we map at the radius on the horizontal direction from A, we have this distance here, right? And this distance here is R cos 45 degrees, which is basically equal to 75 millimeters cos 45. So therefore, this distance here from A, this one here, this is the one I'm talking about. Let me draw it, I take it a little bit down. All right. So this one here is the one I'm talking about. So it's 75 millimeters. So we need to convert 75 to meters. And if we did so, this becomes 0.075, then cos 45 degrees. All right. So let's take moments now before I mess up my free body diagram, and after that, then I'll divide this into components. So I'll say summation of moments about point A equal to 0. All right, what do I have here? I have 4 there. It is going to cause a clockwise moment, which is negative. So 4 by 0.075 cos 45 plus MA is equal to 0. Therefore, my MA is going to be equal to, let's do calculation 0.075 cos 45. Right, since it's a small number, I'll convert it to newtons. So this becomes a 2.13 newtons meter. Alright, we found this. So now let's find the components of normal and shear force. So before we do so, we need to divide this into x and y. Let's start with the shear force. So shear force is going to have a downward component like so. Let me just shorten it a little bit so that I have some space for the other one. Okay, it is going to have something like this. Okay, and then it will have another component in this direction. All right. Okay, it's going to have another component in that direction. So since we have 45 on one end, it doesn't matter which one we pick as our 45. Let's pick this one as our 45. So if you do so, this one becomes VA cos 45, and then this one becomes VA sine 45. NA is also going to have two components. We have one in this direction like this, then we have one in that direction like that. All right, so since it's 45, all the angles are 45, doesn't matter which one we pick. So let's say we pick this one as our 45. Okay, therefore this becomes NA cos 45 degrees. This one becomes NA sine 45 degrees. We know that sine 45 is equal to cos 45, right? So now let's apply the equations of equilibrium, that's in the x and in the y. So summation of forces in the x direction equal to 0. What we have? We have minus VA cos 45 plus NA sine 45. Since cos 45 and sine 45 are equal, therefore our VA will be equal to NA. And then now we have summation of forces in the y direction equal to 0. Okay, what do we have? We have a 4 minus VA sine 45 minus NA cos 45, and this is equal to 0. Since VA is equal to NA, we can replace whichever, right? So let me double the VA. I replace NA with a VA and maintain just one angle there because these are equal. Doesn't matter which one you could have used cos 45 or sine 45 there. Therefore, our VA, which is equal to NA, will be equal to 4 divided by 2 sine 45. So this gives us a 2.83 kilonewtons. Okay, so we have our MA like so, and then we have our VA like so. All right, I guess we are done. And I hope the video was helpful. If it was, give me a thumbs up, like my video, continue sharing my videos, and continue subscribing. Bye bye, and I'll see you in my next screencast.